degree of dissociation is a fraction of a molecule dissociate or decompose into a smaller molecules, ions, or atoms. The formula is the change in concentration of reactants over the initial concentration of the reactants. And to find the percentage of the dissociation is equals to the change in concentration of reactants over the initial concentration of the reactants times with 100%. As an example, consider the reaction PCl5 gas in equilibrium with PCl3 gas and Cl2 gas. We have the value of the Kc, which is 0.04. If 1 molar of PCl5 is allowed to reach equilibrium at 250 degrees Celsius, calculate the degree of dissociation of PCl5. So we already have the initial concentration of the PCl5. To get the degree of dissociation, we have to use this formula, which is the degree of dissociation is equals to the concentration change of the PCl5, okay, over the concentration initial of the PCl5. As usual, construct your reaction table. So since we have the Kc and also the concentration here, we are going to use the reaction tables in terms of the concentration. So we have the initial concentration, the change in concentration, and also the concentration at equilibrium, right? So we have the initial concentration of the PCl5, which is 1.0 molar. Okay, so since the question didn't mention about PCl3 and also Cl2, we put it as 0. Okay, and then the change in concentration. So since the product here is 0, the reaction will proceed to the right. Okay, so it will increase in X, and then decrease in X. Okay, so at equilibrium, okay, the PCl5 is 1 minus X, and also for the PCl3 and Cl2 is X. So find the value of X because we need the change in concentration here, okay, to get the degree of dissociation of the PCl5. So how are we going to get the value of X? Okay, so since we already have the Kc value here, so we need the Kc expression. Okay, so the Kc expression is equals to the concentration of PCl3 times concentration of the Cl2 divided by the concentration of the PCl5. Okay, and then substitute the value. So we already have the value of the Kc, which is 0.04, is equals to X for the concentration of PCl3 and also X for the concentration of Cl2 over 1 minus X. And then solve this, find the value of X. And then again, press your calculator, okay, menu, okay, choose the equation, okay, so we have the equation alpha A, and then select the polynomial, okay, so we have a second degree, okay, and then put the value of A here, so x square here we have 1, okay, equals, okay, the p value here is positive 0.04, okay, so 0.04, press equals, and then the value of c here is negative 0.04, okay, so press negative 0.04 and then press equals, press again equals button, okay, and then we have the first value of x is 0.181 and the second value of x is negative 0.221. If we substitute these two values, okay, so if x is equals to negative 0.221, we will get the equilibrium of PCl3 and Cl2 at equilibrium in negative value. So since concentration cannot be in negative value, we are going to ignore this value. Okay, so x is equals to 0.181 molar. So the concentration of the PCl5, the change in concentration of the PCl5 is 0.181 molar. So substitute these two into this formula. Okay, we have the change in concentration. Ignore the negative sign. So we have 0.181 divided by the initial concentration of the PCl5, which is 1.0 molar. We will get the degree of dissociation of the PCl5 equals to 0.181. So the degree of dissociation got no units. Okay, so this is the answer for this example.